Good morning, Professor. Hello, everyone. My name is Ashish Verma. I'm from Sunset, San Francisco. And today we are going to talk about data project, which is nothing but predicting the price of the cryptocurrencies using the web scraping, basic machine learning algorithm, and deep neural networks. So mm, uh, instead of Bitcoin, we can use any other cryptocurrencies. Just need to filter out those cryptocurrencies symbol in the web scraping API as well as in the Yahoo financial API, and we can get the corresponding data. So idea here is to the problem with the cryptocurrency is that they are very fragile and volatile. The prices of the cryptocurrencies changes every now and then with every second passing. There is a lot of fluctuation we observed, and it is very difficult to predict the price of the cryptocurrency at any given point of time. Though in this project we have tried to gather and do some sort of information gathering from different API web scraping, and we try to find out the price of the Bitcoin price for the next day, given that we have the table closing price for the previous day, right? This project is basically divided into three steps. First, we are trying to predict the price of the cryptocurrency or the Bitcoin using the basic machine learning algorithms. Then we are using a deep learning algorithm using a PyTorch, and I have also included TensorFlow related deep learning models to predict the price of the cryptocurrency for the next day. Right? Identify the data sources, data acquisition, web scraping, pre-processing of data, exploratory data analysis, outlier detection, feature engineering, architecting the machine learning model, architecting the deep learning models, saving and the deployment of the models um, in the Google Drive and the Colab directory, and then using them later on for making the predictions. Okay. So data sources which I'm using is the Bitcoin Cap is the website and the Bitcoin info chart. There are two websites which I'm using. Also, I'm using a Yahoo Finance, uh, uh, a Python library which is called Y Finance, and I'm also using there's something called Quandel that is a Python library for the Nasdaq data link to get the data for the Bitcoin related data. Apart from the closing price or the opening price, high, low, there are certain other features are associated with the Bitcoin prices, right? So, right. So, first step is to get the data acquisition. Data acquisition is nothing but how are we going to get the data to perform the analysis of this. So, this basically deals with the web scraping part, where I try to web scrap the data coming from the coin market info website, right? With the help of the method called web scraping, where we need to pass the URL of the website um, and the corresponding timestamp, and we will get the Bitcoin data available there. Historical data, I'm passing the Bitcoin USD as a code, and the start date of the API is 2015-001, right? And the historical data will be connected in a sort of a data frame using the pandas I'm collecting. Then I'm also collecting the um, other uh, other fields which are associated with the bitcoins, right? What is the price of the Bitcoin, number of transaction happening in a day, number of addresses sent, and by the receiver, what is the mining difficulty we are getting, what is the hash rate, what is the probability of the Bitcoin in a given day, average median transaction fees if somebody buys and sells the Bitcoin, right? What is that average time in a block where it is gets stored, median transaction value, miner value, and other features I'm correcting, so that the more number of features we provide to our model, the better are the chances it will predict the correct next day price. Okay, so in the notebook, I'm trying to accumulate all the fields one by one and then concatenating into a data frame. So as we get down, the number of fields in the data frame gets increases. So final data set with the historical as well as this current data set will have close to 26 fields, close to 24 rows will be there. 24 features we could say will be available, right? Then after once we collected the data, there are certain pre-processing steps I am doing. So these pre-processing steps include when we are generating the label. So I'm making the label as a next day closing price from the current closing price, replacing the null values with the NaN values, converting of the data type to the float type, get the data frame summary. Summary is nothing but the details of the data frame, like whether do you have any duplicates there, how many values are null there, right? So that information is available in the summary part. As you could see here, I am calling get summary method and passing the data frame information. So it will show all the data types, if there are any nulls available, unique records available, any duplicates available, mean, median, mode, etc., to get the high level information. And interesting part was here, I was trying to get a data from Python library called InvestiPy. InvestiPy has now been decommissioned because of their clashes with some of the sourcing team. So for that, I need to go with the web scraping part there and use the Yahoo Finance Python library available. A certain exploitative analysis based on the finding the correlation metrics as well as the trend of the data over the past year, and each of these motivations of the fields, how they are associated with a particular date, right? So let me minimize this part. As we can see here, this is my first price motivation, right? So what was the price correlation of the other feature with the next day closing price? So what are the correlation between the closing price as well as the other features available in the data frame, right? As you can see towards the dark blue region, like uh, closing price, minor revenue, opening price, these are closely related with the closing price than with the mining probability and other. And also we could see the, okay, maybe in Chrome it is not visible. And also we could see the data, how the data has been, how is the normal distribution or the distribution of the data starting from the beginning till the end of the time where I'm now coming to the next part is called feature engineering. So though we have close to 27 to 25 fields, we also need some other feature so that our model can best predict the data. So for that, I have used a couple of averages that are usually done on top of the continuous features or the numerical features are there. So those feature engineering part, which I've included in our notebook, they are simple moving average, weighted moving average, exponential moving average, and with the statistical part, I have included, there's a class written data smoothing. Under those class, all the basic functions I have written there. So we have the variance, we have the standard deviation, we have the relative index, strength index, we have the receiver operating characteristic, we have the double exponential moving average, triple exponential moving average, and moving average convergence and divergence indicator. that will help us to understand which feature to include in our model and which feature to include, not to include in our model. Important concept called standardization. So standardization of the numerical data is very important between. So standardization nothing but take the value, subtract with one mean and divide it by standard deviation. That we can do manually, or we can use a scalar, which is available in the sklearn library, which is called robot scalar, min-max scalar, or standard scalar, and even we can use depending upon the model performance and other hyperparameters, right? So in our case, we have used robots scalar and scale the data. As I have used the certain modeling examples here, which are model selection and what is the reason for each of the model selection. So we have the dummy regressor just to make a dummy regression, and we can, that's kind of a baseline regression we have taken so that we can later we can optimize and use other regression algorithm. Support vector regression I have taken, linear regression I have taken, XGBoost regression, Huber regression, and quantile regression. Then we have the Huber, which I have considered as the model. We could see that the red as well as the yellow lines are very closely overlapped with each other, and we could see the price for the today's closing price I have predicted is 40,383, and price which was closed yesterday was 44081. So some analysis why there is a gap available. There are certain papers I have collected and a hypothesis why this would not be available. It is available in our notebook available. I had some time, so I did some TensorFlow related deep learning algorithm as well. Contrary to the PyTorch, TensorFlow do perform well. I did not make any predictions of the data, but I do, with the help of the train and a Tesla, we could see it's kind of overlapping, right? And you could see data, and this is the overlap, right? Comparison between the closed price and the predicted price coming very closely with the TensorFlow, but not as the PyTorch implementation.